This is part of the lecture for multivariable calculus, and I'm going to talk about triple product. So if we have three vectors A, B, and C, I can write B cross C, and then I have the dot product with A. I cannot change it like that. Why? It's just because B dot C is a number, the dot product is a number, and then a number cross product with a vector is not defined. Okay, so this is called triple product of them. How do we define that? We're gonna say that it's determinant of, I'm gonna put the components of A on the first row, the components of B on the second row, and the components of C on the third row. And we're gonna say that this is actually the volume of parallelepiped. What is a parallelepiped? I'm gonna have B and then C, and then let's say that this is the vector A, and I'm gonna make a parallelepiped. This is a copy of C in here, this is a copy of B in here, and then this is a copy of C, and this is a copy of A. So this is a parallelepiped, and the volume of that would be this triple product. Why? It's just because, you see, B cross C is a vector. So let me write A in here, and this is B cross C, and the vector B cross C is perpendicular to the plane that is passing through B and C. And as you know, the area of this parallelogram in here would be the length of the B cross C. So the area of the base of this parallelepiped is B, the length of B cross C. And how about the height? The height, I need to find the height of this parallelepiped, and for that I'm gonna say that, for example, up to here it's the height. For finding the height, if I say that this angle in here is the angle theta, okay, then I can say that the height would be the length of A and then cosine of the angle theta, the angle between A and B cross C. Okay, therefore the volume of this parallelepiped would be the length of A, the length of B cross C, and then cosine theta, which would be actually definition of the dot product B cross C. Okay, that's how we define a triple product. And let's solve some examples about triple product and also more examples of cross product in the next video.